Hello everybody, and welcome back to Space Engine. I'm gonna take a break from talking about the moon landing conspiracy theories because they are boring and basically you can't get any headway with them. Anyways, we're gonna talk about something actually interesting this episode. Of course, I'm talking about Mars. Now, NASA recently announced that they had actually detected conclusive evidence of flowing water on Mars, and everyone's like, well, that's pretty cool. Of course, the knowledge that ice has been on Mars has been known for a very long time. Like we've known about ice, like water ice on Mars for quite a while. So water on Mars isn't really the big amount. The discovery, the big discovery, was finding that flowing water is actually flowing on Mars today, because we before this thought that the water was all locked up in subsurface ice or whatnot. But it appears that the water is actually still able to flow sometimes due to some circumstances. Mostly because it contains a lot of different ice or salts, like disulfides and whatnot. Time paused. Nope. Actually, what was it? It was like magnesium dichloride and something like that, and some other stuff. Either way, ooh, it's not. I should just turn off spaceship mode. The salts in the water reduce the freezing point, for one, like normal salt does, but they also reduce the evaporation rate of the water, which is really important because Mars has a very thin atmosphere, so water boils away a lot faster than it would on Earth. Oh, there's Valles Mariners. The Valley of the Mariners. So yeah, the flowing water was really cool, but of course there were some people who got not some people on the internet I should say have gotten mad because they were all like, oh cool water, let's go investigate it with the rovers, because the water flows were actually found to be within 50 kilometers of Curiosity, but Curiosity is not allowed to go near the water. In fact, none of the rovers on Mars are allowed to go near the water at all due to the Outer Space Treaty. And a lot of people got upset about this for whatever reason. It's like, okay, it just means that the rovers aren't sterile enough. They don't meet a certain level of sterility to allow them to go to the to explore the water areas. It's like there's been even before we discovered these water flows on Mars, there have been locations on Mars which have been designated as no-go zones for manned exploration and even unmanned exploration for the time being, just because they don't want to cross-contaminate bacteria from Earth onto Mars and destroy a possible Martian ecosystem. So it's land, and it still applies to these water zones because Curiosity and Curiosity and Opportunity, I think are still. Opportunity I think is still alive. I think Spirit's the one that died. They both went through sterilization programs before going to Mars, like all spacecraft that land do. However, it doesn't meet the high enough sterility to allow exploration of potential Martian ecosystems. Because in order to make sure it was 100% sterile, you'd have to blast it with either really high heat or really intense radiation, and that would damage electronics. So they were only able to sterilize, they're very clean comparatively, but there's still a chance there's some microbes in or on the rovers that could cause some problems if they encounter the water and contaminate and blah blah blah. This treaty has been signed since 1967. Like it's been a big part of space exploration for the longest time, and it's as much to protect other planets as it is to protect Earth, because it helps prevent cross contamination. If you send something to another planet that has potential ecosystems, you have to make sure it's really clean. And if you bring stuff back from other planets, you have to make sure the samples are quarantined heavily. Granted, back in the day, this was done for the moon, so like moon samples were quarantined heavily to make sure there weren't any bacteria or whatnot. There weren't in the end, but still, they wanted to make sure. So now people are like, people are like, it was weird because I saw these one arguments. People are like, on Earth, we don't care about blowing up nuclear bombs in the water and dumping sewage into the ocean, but we're afraid to potentially put some microbes into Martian water. And it's like, yeah, just because we cause problems to our own planet doesn't mean we can go and trash another planet. And also, there is currently life on Earth, so it doesn't. Well, okay. A lot of those things are frowned upon. In fact, all of them are frowned upon. But contaminating Earth with bacteria from Earth is not a big deal because we already know there's life here and we know of it. With Mars, we don't know if there is life there, and if there is, we want to make sure if we do find life that it is native to the planet. So if you bring Earth life to Mars and accidentally screw it up and contaminate it, if you find life there, you can't say for certain whether or not that life is native to Mars or if it was brought to Mars from Earth because of poor protocols. So the reason why they have that no one can explore those zones just yet unless they have a vehicle that's meets the standards is because they want to make sure that if we do find life in these areas, they are for sure Martian life. Now, of course, there is the idea that life on Mars and Earth actually share a common ancestry, because Earth, Mars, and Venus all shared material quite frequently throughout the early years of the solar system. Ooh. So there is a very good chance that there's a lot of material that's Venus that was exchanged between the two. In fact, we have quite a few rocks, meteors on Earth that did in fact come from Mars, and vice versa. And also Mars was actually habitable first, like it was habitable before Earth was, and Venus was as well, theoretically. So there's a lot of conjecture as to whether or not life on Earth started on Mars and then was seeded onto Earth, or if it started on Venus and then was seeded on Earth and then subsequently Mars, or if it started on Earth and then was seeded on Mars. And there's all this whole Panspermia theory that if we find life on Mars, it may very well be related to us to some degree. What's that? Jupiter. Let's not go to Jupiter. So, again, if we find life on Mars, there's still a chance that it will share similarities to us, and if it does, then that'll confirm that, well, we're from somewhere. It'll solve the question whether or not life is exchanged between planets. What it won't solve is which planet started first, because both Earth and Mars had materials needed for the development of life early in their development, so I wouldn't be at all surprised if life started on Mars first, because Mars is half the size of Earth, it cooled faster, it had liquid water sooner, and had a more pleasant environment sooner. So there's a chance, anyways. And there's also the idea that during the early heavy bombardment, when Earth was still forming and was getting slammed by meteors all the time, a lot of these impacts would have sterilized the surface. So it's like if you had life that started on Earth and then a large chunk came and slammed into it and sanitized the surface, how does life survive that? And there's the idea that either there were parts of the planet that were little oases that weren't sanitized by these impacts, like deep underground, deep in the oceans, or just parts that cooled off sufficiently to allow life to survive in between impacts. There's also the idea that during these impacts, it sanitized the surface, but also launched up a crap ton of material into Earth's orbit that contained microbes that had been evolving in the ocean. And by doing this, they basically act like little life rafts, where the bacteria would then lay dormant in these meteors orbiting the Earth for thousands of years, maybe even millions of years, and then they'd crash back into Earth's oceans and reseed life so that life could pick up where it left off. And there is actually some validity to that theory, or at least to the theory that our bacterial ancestors spent time in space, because quite a few microbes that we know of on Earth, and like even some of the oldest ones, like cyanobacterias, can survive very heavy levels of UV radiation that they would never have to experience on Earth, like where they live. There's no reason for them to have developed the resistance to radiation unless they, at one point, the life had kept experiencing high radiation environments that made them develop this resistance. And so there's the thought that that could be a telltale indicator that that life on Earth spent some time in space in some way. Either it was, we're on the wrong side of the ecliptic, either it was transferred between planets, or if where's Mercury? There we go. Or if it was just like it was launched into orbit frequently. So there's a lot of interesting ideas about this, and this also brings up the idea if life can be transferred between planets, can it be transferred between star systems? Oh, time's going pretty fast. How do I slow down time? Nope. Nope. I really should have like a little, what do you call it? No. Whatever. Oh, I turned on indicators. I should probably turn those off. I wish I have a little piece of paper that tells me all the different commands. Because I feel like I'm bad at this. There we go. And then I turn that off. Excellent. Anyways, oh, Jesus Christ. So there's the thought, if life can be transferred between planets, can it be transferred between star systems? And this is, I forget what the theory's called. It's similar to panspermia, but basically it's the idea that life starts in a few little locations in any given galaxy. Life will chemically start on in a few star systems, but then ultimately spreads around the galaxy through debris from early development and whatnot, and life will actually spread around the galaxy. So you have a lot of stuff, like a lot of different. You have a lot of life compacted in a relatively close range around various things, and yeah. So it's like the only way to really prove or at least give credit to that theory would be to catalog large swatches of the galaxy, which might be a little tricky because if we find that life is spread evenly or roughly evenly throughout the galaxy, that'll indicate that life, for the most part, starts independently of independently of one another, and it just kind of spreads between planets, and it might spread between stars, but for the most part, life is indigenous to its various star systems. But if we start cataloging thousands of different worlds or millions of different worlds throughout the galaxy, and we find that there are pockets of life, like you know, there's a stellar neighborhood where you have maybe 100 stars, and within this group of 100 stars, you have 50 stars that all have life-bearing planets, and they're all fairly relatively close together. And then outside of this 100 light-year distance, you have just in all directions emptiness where there's no life to be found on any of these planets, even ones that could be suitable for life. It's just not there, and that would give some credence to the idea that life spreads throughout the galaxy like a disease, I guess you could call it. Only it's not a bad disease because life is cool, and I don't like misanthropes, or anyone who doesn't like humanity. Anyway, so like, you know, there's a lot of interesting ideas, but that'll again that would require us cataloging life on other planets and also looking at genetic markers. It's like even if the life has changed a lot, you're going, ooh, I almost missed that. Even if life has changed a lot, there's still going to be similarities in the genome that'll show indications of ancestry to one another. So, for example, like if you go to Mars and we find life, if it is pretty much spot on with life on Earth, then okay. If it is spot on, then yeah, okay, it's contamination. If it's relatively different but has similarities, then that gives credence to the concept that, Jesus Christ, that gives credence to the idea that life had been exchanged between Earth and Mars at some point. There's a planet with life around here somewhere. And people keep telling me how to find them using, like, oh, there it is, using the different colors, but whatever. Anyways, and so if you look at these similarities, there we go. Sorry, it's late. I haven't done a video in a while. Then yeah, this would be show a correlation between panspermia theory. Alternatively, if we find life that has like no similarities at all, aside from maybe basic chemical like similarities, maybe Martian DNA consists of 4 base pairs like Earth DNA, but the proteins are all left-handed instead of right-handed, or because like what is it? It's like different protein. Oh no. It's like proteins in, no, I don't want string log, I want information. Wasn't that tab? Or was it caps lock? Info. Yeah, white super. Wait a minute. That's the star. I want the planet. Anyways, so it might have the same number of base pairs, but the base pairs will be arranged differently. And life on Earth, like it has a particular. It's called like right-handed, left-handed. It's basically the shape and the something about the protein structures. I forgot what it is. It's like its alignment or how it's polarized. There we go. And all life on Earth, doesn't matter where it is or what it all has the same polarized like biochemistry. It's all, I think, left-handed is what they call it. So, that's how you can tell, no matter how different life is on Earth, it's all related. It's because it all shares the exact same kind of polarization. So if we were to find life on Mars, and it had the same kind of protein structure, or had the same DNA structures, but its polarization was different, that would say, okay, look at that, or it's indigenous to Mars and not, it hasn't been like exchanged material between various planets. Or if we find it and it has different base pairs, because they have been able to make different kinds of base pair material or different kinds of genetic assemblages in the lab. You can actually have three-tiered DNA. So instead of having a double helix, you have a triple helix. I don't know how stable it is, but it can apparently happen. Or you can have this kind of DNA. It's a manufactured form of DNA. I think they call it xRNA. But it's actually more stable than DNA, which is the scary part, because then you can actually use it for bad things if you really wanted to. But so there are different types of DNA or different ways it can be exchanged, or even if you have life that's not even carbon-based, you can have a genetic code where you have these DNA or genetic molecules that are produced using instead of carbon as the base, as like the backbone, like carbon, nitrogen to make the or carbon, nitrogen, and phosphorus to make the structures and all that. You could have something that's based on like silicone and something else to make the structures, or even even a lot of the metallic materials possibly can form genetic structures. So it's like if we were to find life on Mars that had a completely different biochemistry, then yeah, okay, it is most certainly indigenous to Mars. Although I suspect we're going to find carbon-based life on Mars because its environment is very conducive to that. Same with Titan. Now the thing with Titan, and Titan, Europa, and Enceladus, and even Triton, is the further out into the solar system you go, the less likely materials exchanged, and the less likely it is to be exchanged, for that matter. So it's like Titan is far, or Europa's still close enough that material might have been exchanged between it, Mars, or Earth. So life could have been sent from Earth to Mars, and then from Mars to Europa, in a kind of stepping stone thing. But Europa's still far enough away that the chances of panspermia are a lot lower. So if you find life on Europa, oh, I something with life. So if we find oh, I lost it. So if we find life on Europa, there's a really good chance that it is indigenous to Europa, and there we go, and it is not contamination from other planets. And further out you go, the more applicable this gets. Like if you find life on, if you find life on Titan, anyways, I already said Titan, it's far enough away. Or if you find life on Enceladus, which is also on Saturn, again, it has a far lower chance of being from contamination. And if you find life on Triton, which is around Neptune, edge of the solar system, it is very, very unlikely that life there was from material sent from Earth or Mars or Venus or any of the inner planets. So it's like the further out the system you go, like these have been modeled and stuff, the less likely it is, like the less material exchange you get. In fact, Triton looks very similar to Pluto in its structure, actually. And it also has a retrograde orbit, so it orbits in the opposite direction. So they suspect that Triton is actually a Kuiper Belt object like Pluto that was snatched up by Titan or by Neptune and turned into a moon. So there's the joke that or it's kind of a joke where it's like you have Triton was Pluto's girlfriend, but then he was stolen by Neptune because she likes big planets. Anyways, so yeah, you have these concepts of further away from life zones you have more likelihood of finding indigenous life instead of transferred life, unless life transfers just naturally throughout the universe, just anyways. What is that? What is that? Is it a little volcano? The hell? Whoa, we found something weird, guys. Is it a graphical glitch, or are we finding an alien city? I'm really confused. I think it's a graphical glitch, because I can see right through the planet. I think it's supposed to be like cracks around an impact or something, and it just has been broken. Anyway, so yeah, I guess I started talking about why we couldn't explore the water zones on Mars for contamination, and we turned into Panspermia, but that's always interesting now, isn't it? So yeah, I should probably end this now. It's been 21 minutes, but always fascinating. I love talking about the prospects of life in the universe and it propagating, and oh man. This is really strange. But I kind of like it. That was a nice little interesting find. There's the impact craters for the ejecta. That's just lovely. It is just lovely. It's another little impact zone. It looks like it's these little... Oh, they're volcanoes with lava flows. And the lava flows are breaking it. That's weird. If I had any immersion, that would have broken it. But thank goodness for that. So yeah, I think I'll end it there. Thank you all for watching. I hope you enjoyed. I'll be doing a lot more often. I do apologize at the beginning of all my videos for not doing stuff frequently, but I realize you guys know that I don't make videos regularly. I make them when I have the time, so I just assume you guys aren't mad at me for being very spastic in my uploads, but I'll try to do a little bit more as I can, but again, I'm busy, so you never know. Thank you all for watching. I hope you enjoyed, and space